This is Anthony Precella coming back after our break. Continue to introduce some of these solving not logarithmic equations. What are these? Trigonometric equations. So, let's see. Sometimes we have to use identities to get it written with just a single trig function, or get it written as something we can factor with, so that we have just one trig function in each factor. And we're up to doing number 15. I'm going to do this one. Find all the solutions over the interval 0 to 2 pi. 2 sine 2x sine x minus 3 cosine x equals 0. Well, if we could somehow factor this, and I don't see a way we could factor a trig function out of this, but there's something that's just sort of staring you in the face and you've got to spot it. That's sine 2x. We have an identity for that. What was the identity for sine 2x? It was 2 sine x cosine x. If I replace this circled sine 2x with 2 sine x cosine x, then we have this blue 2 times this 2, so that's going to be a 4 sine x cosine x times sine x. That would be sine squared x cosine x minus 3 cosine x equals 0. You might think, well, what did we accomplish? Why was that important? Well, now when you look at this, do we have something that we could factor? Yes. What trig function could I factor out of each term here? Well, I could factor a cosine x from each one of these. If I factored a cosine x from each one, what's going to be in the parentheses? Well, that'd be gone and that'd be gone. So we'd have a 4 sine squared x minus 3 equals 0. Did I factor that right? Yeah, I did. How do I know that? I distribute this cosine x. I get 4 sine squared x cosine x minus 3 cosine x equals 0. Set each one of these factors to 0. So we have cosine x equals 0. And 4 sine squared x minus 3 is 0. So move the 3, divide by 4. We'd have sine squared x equals 3 over 4. Now here's what we were talking about earlier. With that squared there, you don't just take the positive square root, you take the positive and negative square root. So you're going to be looking at the unit circle, asking yourself, where is cosine 0? And where is sine positive and negative 3 pi over 2? So cosine is 0 at pi over 2. Pi over 2 and at 3 pi over 2. So purple solutions. Pi over 2, 3 pi over 2. Now where is sine equal to plus or minus? Ooh, what did I do wrong here? Square root of 3 over 4 is not 3 over 2. It's the square root of 3 is square root of 3, square root of 4 is 2. So plus or minus square root of 3 over 2. Where is sine square root of 3 over 2? Well, at pi over 3. So it's going to be at all of the over 3 ones. Here's sine, the 2 pi over 3 sine is positive. At 4 pi over 3, it's negative square root of 3 over 2. At 5 pi over 3, it's negative square root of 3 over 2. So all of the over 3's. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So that was number 16. Find all the solutions. So there's a lot of them. You have to type them in. Pi over 2, comma, 3 pi over 2, comma, pi over 3, comma, 2 pi over 3, comma, 4 pi over 3, comma, 5 pi over 3, comma. Okay. Now let's go back to number 10. How would we solve number 10? Tangent square theta minus 4 secant theta equals negative 5. It's problem 10 we're doing. Can y'all think of an identity or some way we can get just one trig function? So that brings to mind tangents and secants. What are you thinking about? Maybe a 1 plus tangent square theta equals secant square theta. So in other words, tangent square theta is secant square theta, minus 1. Okay? So tangent square theta, secant square theta minus 1. So that's what I'm going to do here. To get just one trig function, I'm going to replace the tangent square theta with secant square theta minus 1. And now let's get it written as a quadratic equation. I'm going to move the 5 over. I'd write it as secant square theta, then a plus 4 secant theta. And is this going to be a plus 4 once I move the 5 over? So let's see how we would factor this. Well, secant theta and secant theta. Second sign is plus, 2 of the first, so both pluses. 1 times 4, 2 times 2. What's going to give me that middle term? Yeah, 2 times 2. So we want to write this as a perfect square trinomial. Secant theta plus 2 all squared equals 0. And set each one of these to 0. So just set one of them. Secant theta plus 2 is 0. So move the 2. And you know what I'm about to do? I'm going to write this in terms of, what's the reciprocal of secant? Is it cosine? So if the secant of angle theta is negative 2, the cosine of angle theta would be negative 1/2. So where is cosine negative 1/2? Let's see, we were told to do this in terms of degrees. 0 to 360 degrees. So where is cosine negative 1/2? Well, that would be at 120 degrees and at 240. So 120 degrees and 240 degrees. So cosine is negative 1/2. Oops. Cosine negative 1/2 at 120 and at 240 degrees. Cosine is also negative 1/2. So there's number 10. I used the fact that 1 plus tangent square theta is secant square theta. So tangent square theta is secant square theta minus 1. So that's what I did first. Then I move everything over to get a 0 by adding 5 to both sides. And I have a nice quadratic equation I can factor. In fact, it's a perfect square trinomial. And once I have secant theta equals -2, I'm just going to think in terms of the reciprocal. Cosine theta is -1/2. And look at the unit circle. What about number 8? Let's see, how's number 8? We found a blank sheet of paper. Number 8. Not number 8, number 11. Where did I get 8? Oh, there. Number 11. Move it on up. Well, right off, I think I'm going to divide straight through by 8. That'll get rid of those 8s. So we have the equation sine squared theta tangent theta plus sine squared theta equals 0. Now this one, I think we could just go straight to factoring. If you just factor a sine squared theta out of each of these, you're separating the trig functions. What would be in the parentheses if you factored a sine squared theta out? We would have a tangent theta plus 1. Now set each one of these to 0. How did we get this one in the middle of all these hard ones? This is one of those where you don't have to do plus or minus. Plus or minus 0 is just 0. So sine squared theta is 0 means sine theta is 0. Take the tangent theta plus 1. Move the 1, tangent theta is -1. So where on the unit circle is tangent 0, or excuse me, is sine 0? Where is tangent -1? Sine is 0 at 0 and at pi, or is this one where we're told to write it in degrees or radians? Radian. No, degrees, 0 to 360. So sine theta is 0 at 0 degrees and 180 degrees. 0 degrees, 180 degrees. Now, where's tangent -1? Would it be in quadrant 1? But it is at all the over 4s, but not in quadrant 1. The over 4, sine over cosine, that would give me -1. So that's 135 degrees. And not in quadrant 3, sine over cosine, that would give me a +1. It's the over 4 here, 315 degrees, sine over cosine in fourth quadrant. That would give, so 315 degrees. So 0 degrees, 180 degrees, 135 degrees, 315 degrees. Number 12. Let's see. Well, there's secants and tangents, so you might be tempted to say, oh, let's do it like number 10. But I don't think we need to. If you look at, if we just move this 12 tangent x, well, first I'll divide through by 6. So secant squared theta tangent theta equals 2 tangent theta. Move this over. So it's a -2 tangent theta equals 0. Factor the tangent theta from each term. Flip the light switch off. So we have secant square theta minus, what's going to go there, 2 equals 0. So we have tangent theta equals 0. And secant square theta equals 2. So this is one of those plus minus. Secant theta is plus minus square root of 2. I think I'm going to go ahead and think of it in terms of cosine. If secant is the, if secant is square root of 2, cosine theta would be its reciprocal, 1 over the square root of 2, but you rationalize to get square root of 2 over 2. So that's what I'm looking up. Where's tangent theta 0, and where's secant theta square root of 2 over 2, plus or minus. Well, tangent would be 0, sine over cosine. Sine over cosine. So here at 0 degrees and 180 degrees, yeah, this one. So the first two solutions, blue ones, 0 degrees, 180 degrees. What about the red solutions? Where's cosine plus or minus square root of 2 over 2? It's at all of the over 4s. Plus or minus, or 45 degrees. So it's all the ones that end in 5 degrees, 45 degrees, 135 degrees, 225 degrees, 315 degrees. So these are some nice trig equations. Very big major topic occurring here. Okay? So key to simplify or to solving a trig equation, if you can factor it in such a way that you separate out the trig functions. Okay? That's it. Through solving trig equations.